don't spend too much time on inventing the new features. Just try to see that how difficult or easy is it to add any new functionality that you want to add into this. Don't spend too much time to make the game beautiful. Like so that's there is no grading for making the game like really awesome. If you want to do, you can do that as well.
Yeah, I tried. It's just not
Okay. More resources on Maven. You will certainly read a little bit more about Maven. So next part that we really want to talk about, and that's where this whole component-based system thinking gets kicked in, is about thinking in terms of component for your architecture and design. So imagine you are building a again very simple example, and but this really highlights this whole component-based thinking approach. So imagine you are building a calculator application, which is like which has a calculator service as the core functionality. That's a sort of business logic. And you have a UI, which is basically the entry point for your application, and you are interacting with that. Right? So if you just build this, if you have just direct implement that in your main functionality. So what is the issue with this current implementation that you see? You hope you all understand the the UML notations, and I assume that you have good understanding of the UML notations. And okay, so what is the issue with this? Let's say I want to implement a calculator sort of thing. So this is my uh, age calculator sort of app, and this is age calculator that actually does the calculation part. This is like the app itself, like it's an app that has a calculator inside. So, and this is sort of my design. If I have this design like this, what is the issue with this? Any thoughts that comes to your mind? If you were to design a build system like this,
It's only made of one component.
yeah, it's just it's about one. So there are two part like two components, but and one is just the service, and one is the calculation functionality. Another is just the UI that which uses that and shows you the basic.
I know this example in the book from here.
Yeah.
It said it was tightly coupled, as I recall.
Yes.
And built, so if one doesn't work, it's just wow.
Yeah. So that's really good example. We will touch upon that and see how. Any other thinking that comes to your mind? What is wrong with let's say implementing this, having a design like this?
It's gonna be harder to spot the stuff. For example, if you want to extend the age calculator to some stuff, or we want to change them to line logic, it's gonna be more difficult.
Yeah, that's good. Anything else that comes to your mind straight away? What is the challenge with this? It's a simple stuff, but what is the challenge? Let's say if it was a complex system and you had implemented it like this, what could be the challenge? I think the points that you mentioned are really good, but I just want to see if anyone else also has any other thoughts besides this, or see any other problem with this implementation.
I don't know if everyone could understand, like in the back, what the points were statements.
Oh.
Like, not you, like the points there.
Oh, okay. So he was mentioning about this two tightly coupled. He was also mentioning about two same type coupling that is difficult to replace this component. That's one immediate challenge that everybody could see. Or can you see through or not or don't think there's any issue with this design? That's our main question. Yes, no? But then I think the points that you made that are at the crux of it. So yeah, so if you have like you have direct dependency, so it's very hard. If I want to use a different type of calculator, then I need to replace this, and it's like sort of builds the type coupling for me. What could be the solution for this? You understand that there is a problem with type coupling. It's like you have a component, you're using the core function directly in it. Yes.
Oh yeah, there was kind of like
not from the diagram, but like what it will essentially do is create an object of this one inside your main class or this main app, and in this way, if you want to change this, if you want to change this calculator, you need to change the object that you are creating inside the main to replace it. Let's say you get the point. You straight away, like within this main file, this is your age calculator, right? I have the code somewhere, right? So inside this main file, you're directly creating the object of that particular calculator that you're using, and if you want to replace that, you need to replace that object that you created, and then compile both of these, and then you will be able to like replace it. It's like the coupling is really tight. It's not that I just replace it and my main still runs, it doesn't create a problem for me. That's the main sort of okay, we are jumping way ahead. Okay. So instead of this type coupling, what we could do is we could build an interface that let's say the main application uses the core business features, the calculator service, right? We have an interface that sits in between that provides you the service, basically the calculation service, right? In that case, even if you need to change the edge calculator, this component that or the core business service, this code still works, right? You don't need to create new sort of object in the main. Is that what clear or no? Yeah. So in that, if you place an interface in between these two, then this part is easily replaceable, like without affecting the entire application, right? That interface can help us or solve us, like aid us with, right? And build time coupling can be reduced. But so this basically this solution actually helps you with reduces your build time dependency. When you're building the project, it only cares about this part, this guy. So it compiles, yeah. It helps you with the build time type coupling. It's basically it only cares about this part, and this is replaceable. But this also introduces a problem of runtime dependency. So at the runtime, even if you have the interface at the runtime, it still needs a concrete implementation of your calculator. And so interface helps you with the build time dependency, but it doesn't solve the problem of the runtime dependency, because at the runtime you still need that component for in your application to run. Yes.
An example you showed on what come before, like inside back, isn't that then like using the interface? Isn't that dependency injection?
What?
Is that dependency injection?
Yeah, we'll move to the it's a dependency injection, but like no, this is not an example of dependency. Dependency injection is something that we'll look into, like instead of creating direct objects, we have a dependency and we inject it like via the dependency injection framework itself, and in that way we avoid the direct coupling. But I think we are jumping too ahead. We'll touch upon that a little bit later. Here, what I wanted to highlight is that by introducing the interface, we solve the problem of build time dependency, build time coupling. But the problem still persists, because if you code builds, but at runtime you still need the dependency for it, concrete implementation for it to run it, right? And then that's the build time dependency still persists in that example. So to avoid that, you could actually use some sort of glue code that fits all of them together. So you could have a glue code that sits in between together. Remember the example that we in the first slide, in the first lecture, we were talking about the of let's say 911 emergency center. You call, all they have is your phone number. They look into their address directly. From address directly, they get your address, and that address they put it into the map or Google Map for them to show where you are calling from, right? So it's like you have different components, different subsystems, and then you put a glue code that actually does the linking between these two different subsystems. Similar to that, you basically build the glue code here, that also breaks your runtime dependency. But this runtime dependency is also really hard because it's again hard coded glue code. You need to write a glue code for every component that you have. You have a component, you write a glue code. You have a component, you write a glue code to make everything stick together. And that's also not really efficient way. What we need for this system to be really loosely coupled, and that's where this whole concept of component assembly or the automatic component assembly using component frameworks comes into. So imagine you have a component framework that understands I have this number of components in my application, and any part of the application needs a particular component. You just go to the component registry and then fetch it from there, and then just the component is available throughout your application. In that way, you basically try to solve this problem of tightly coupling. So all you need to do is whenever you have a component, build the component, register it in the registry, and then the listener or the guy who is interested in using that, he just goes to the registry and then basically uses fetches whatever he needs. In that way, it's like they're not directly talking to each other, just talking to registry, and for that they fulfill their dependency. So there are two ways basically that you could, where you have the dependency fulfilled. And the first one is a dependency injection based component model. So there are component models that you could fulfill this via dependency injection. That's a big topic. We will cover it in the next class. But another more simplistic version of that is the whiteboard query-based component model, which in simple parlance is nothing but a registry that you create in your application where each component that you create goes there and registers. So this is again not dependency injection, but it's like registry based. You create a local registry where everybody registers if they need it or if they need to submit the component. And that's called whiteboard query-based model, where you just go and query if you need a component. In dependency injection framework, you don't need to query. The component framework itself knows that you need it and it injects into that dependency for you. That's a bit advanced concept, and that we will cover in the next class. But for now, we will look into whiteboard query-based component model, where with an example. I hope that this concept is clear. What is whiteboard query-based component model? What is dependency injection? So the whiteboard query-based is like, okay, you have a local repository, you go register your component and consume it from there, and that's very simplistic way of understanding it, doing it. Here, the problem with the whiteboard is still that you need to go and ask, right? And to overcome that, you have the dependency injection-based component models, which are more sophisticated, where you just need to declare a dependency and the component will fulfill it. It will know by configuration and it will inject value whenever it needs without you even asking it. That we will cover in the next class. So let's for now just focus on the whiteboard component model.
I have a question.
Yes.
So how it would look like is that we will have an interface inside our project, and then in compile time, something will just pull the component, like the actual core of it, and then it will just work like that? Or
Yeah, so in the component, basically you need to query that I need this component, hey, I need this component, give it to me, and compile it. Yes.
Okay, so,
Yeah.
but we do need to still have the interface to it.
Yes, of course, we do it with the interface. Because then, when you are calling the registry, you should have a standard interface to sort of that the component that you are asking is still mapped. Okay.
Sorry.
Yes.
My second question probably, just thinking like component model is just like how it's structured.
No, component model is like how component model, what it does is like it helps you fulfill your dependencies, how the models are like interacting. It takes care of everything. It's like think of this as a box that knows how to fit things together, where each component is running, has its own life cycle, its own existence, and then it just helps you, has a guideline of how the interface should look like. Remember in the first class we talked about that component should have interface, and what it consumes, what it offers, and all that stuff. It's a standard. And then in this case, wide-based component model is simple model. It's nothing fancy. It's a registry. Let's look into the example, and then things will become much more clear. The more advanced concept, the dependency injection-based frameworks and all, they have really complex sort of component model. They create the beans have their own life cycle. They get injected whenever you need it without even asking. That's something that we will cover a little bit later. But in nutshell, component model is something that fulfills the needs or dependency needs that your app could have at runtime in a loosely coupled way. Yeah. Okay, let's quickly look into this example. Open this in its learning. Whiteboard component model. Okay. And we do it together. Just quickly open it. A lot of moving parts today from Java to component models, but I hope the case was not too overwhelming for you. So let me just open this. So again, we have the same calculator example, just to keep things simple. Always remember this slide when I talk about this one. So we have a registry, we have different components that we need to interact with, and now let's look into the code. So this part doesn't somehow choose. Does it use? No. Doesn't use. Okay. So we have a calculator, age calculator. We have a component interface. You are asking about, do we still have an interface? Yes, we do. We still have an interface, and then we have a component framework. This is whiteboard component framework. Nothing fancy in here. We have a component framework. It has a component registry. What it essentially does is that it is basically when you run this, it registers all the components that you specify here, right? So you say I have this age calculator component. I have this bunch of different components. So this is a very static way of having the component. So declare all of them, run this, and then you have a registry ready for you for others to consume. But this could also be dynamic. You could actually run the components in the registry dynamically. The registry doesn't need to restart, for example. All of that is taken care by these dependency injection frameworks and the more advanced component models that we will talk about in subsequent slides. But this is very simple. Like it's your own component model that you build, which basically it says that hey, I keep a registry of what the components in this application would be, and then I register them. And then in the so here, for example, we have a calculator interface, which is like which this component would register, and then the age calculator application, it would need it, right? So age calculator would need it. Then in the age calculator, it would go and say, hey registry, I need this component, and this will basically fetch this component for you. So it will fetch it from the registry, and then do whatever it needs to do with the business logic. So let's quickly run this. Where is this? So again, it has the three components: calculator, which is like core business logic. Then you have component framework, which is whiteboard framework that we have. The simple framework that we have. We have the component registry, registers the component at the runtime, and then in the main application we use it. in the main calculator app, we are basically using the component registry to give us the particular component that we use. So, how do I run this? Yeah, so basically you have the interface, you have the core business, you have the framework, you have these three main running part, and then in the end you have the application which basically uses everything together for you. So, let's run the main for you. And I hope I'm in the parent folder. Yes, I'm in the parent. And then see in the component registry, this model, this is actually we are initializing this component registry itself in our main application, and the reason being, see this registry has its own life cycle, but since this is a very simple model, we are initializing at the start of our program. We start at the start of the program. We initialize our component framework, which does all the registration part that we need to do, all of this. Where is this? Yeah. So this is a main application where you initialize the component framework itself. Here, this the component framework. Yeah, this code we are calling it here, and here you already have all of these interfaces registered. And this is something that we need to do because this is a simple model. But in real life, in practical, you will have a component registry has its own life cycle itself that runs as a container, and where you can, instead of just hard coding this, you can actually simply it can auto configure if a new component comes. That is much more advanced concept. We do not discuss that here. Wait for the next subsequent classes for that. But here in this case, we initialize the component framework. Then from that, basically it fetches it will search the component registry for this interface, and then it will fulfill this requirement for you. So let's run this, and
That would require each component to be a singleton, right?
not necessarily.
Because if we are storing the instance based on
Yeah, the
on which
component
class
registry.
is
The
storing-
component registry has singleton instance. You should actually have a singleton instance of the component registry.
I mean, the component stored in the registry. Because if we
Yes.
store,
Yeah, but you could also have a different version as well. That's like you have a different version of a same, and depending on the runtime, depending on what the use case you have, you could have different versions. That's likely. And with this simple like component model, it doesn't look like really helpful. But in more advanced frameworks, you actually could register the components at runtime. Like you don't need to stop your container. You don't need to stop your the component framework. It just registers it automatically as soon as the new component comes. How it does, we will see into once we dive deep into those. So let's quickly run this, and all you will see is so it basically is asking the age, and then the date of birth, birth year, and then basically calculates the age for you. This is simple functionality. Nothing is fancy here, but main thing that you should focus on is the concept of component registry that you need to create and register the components. At runtime, it just asks the component registry to give you components. I know for this simple example, it's still very trivial to see the beauty of this, but imagine if you have a big application where you have multiple components and they have different versions, and how do you sort of handle that? And where this whole concept of component framework becomes really, really powerful to handle, to do all of this component creation, registration for you, in a really, really nice way. Okay, I think that's all I have for today. Any questions on the component framework before we close for today? Or anything that we discussed so far? Or even the flow of how we progress, like where we started and where we are now, and how this journey will be like in terms of slowly building up building of the mindset, building of the thinking, how to think of in terms of components, how to think of in terms of the frameworks that will help you achieve this component addition. Any thoughts?
I think example-wise, it's just a lot.
Lot of the examples? Okay. Okay. Yeah,
I
there's some.
think like being introduced to framework is, I guess, is I think it's kind of complex.
Mhm.
Many examples.
Okay.
Maybe it's
You
just
should go a bit slow, or like maybe cut the into two different classes or something. Would that help?
I would prefer that.
I'll keep them in mind for the. Yeah, it's
I
quite a
would
lot.
rather be introduced to the concepts first and go for the framework later. Because now that we went through the whole thing, I think
Framework,
kind of
which framework are you talking about?
maybe.
Maybe. So this is a build tool or something that you would need, because without that, all the examples that we will see, you will not be able to sort of. Yeah, I understand. Maybe one could be just Java and Maven and just get familiarized with this the tool itself, and then jump into this. Yeah, that could be a thing. Keep in mind. Yes. Any other thoughts? See, this component. Okay. Before I close, so what is the problem that you see with this component, the whiteboard component model? What is the challenge that you see? Why would we need, let's say, something like dependency injection? What is the challenge with this? I think I talked about it, but I want to hear your thoughts. What is the challenge? Anything that comes to your mind? Okay, what is the challenge of doing, let's say, things in this way? Whiteboard component model. Yes, anything that's right? Or you want to do the registration manually and.
Still struggling with the concept of dependency injection.
Okay, so dependency.
Trust me, so.
Yeah, so dependency injection comes like this is a pre-step like even for dependency. Now we will discuss about in the next class. We will discuss about the dependency injection. But first, before that, you need to understand what is the problem that dependency injection solves. Right? That's what I'm asking. What is the problem that you have here that actually dependency injection framework will solve for you? Because that is if you don't understand the problem and you are given a solution, then you will not appreciate it. Okay, what is the problem? The problem first is that you need to manually have the registry. You need to manually go and register in the registry, right? Second problem is that the consumer itself need to go and ask for it, right? So that's a main sort of challenge. You have to manually register. You have to manually go and ask. Is that problem kind of understood?
Yeah, I think it's just like.
That's one of the problems.
It's just like a lot of sapiens. I think that's just normal. Like we're still like kind of.
Okay, no, it's pretty normal. Spend some more time. You can more questions. We can discuss those in the next class. So, two problems. One is you need to go. Everybody like if you build a component, you need to go and register the component for others to use. That's one part. The other side of the consumer need to go and every time go and query that, right? And that's also a challenge. Every time you need to go and query, and that's when you get the component. Now you may say, oh, what is the problem? But for small problems, registering and querying doesn't seem like a problem. But moment you have different versions of it, and it's just hell. The whole hell will break loose if you just simply rely on this simple technique. Because how do you manage a different version of a component? And how do you ensure that the moment you deploy it, it reflects across your applications? All the other components that automatically recognize it, that hey, something has changed, that the component has changed, and we need to make sure that we adhere to the new one. So all of that complexity that you can think of in versioning and different sort of components, that is not taken care by the simple model. That is something where the dependency injection framework would be really handy, and you will be able to appreciate. You will revisit this when we discuss that dependency injection framework. But I just want to set the stage that hey, there is a problem with this. Basically, first to go with this, you need to register, you need to query. That itself adds more complexity. So there is a much more elegant way of doing this, and that's what is dependency injection is all about. And dependency injection framework, when we talk about it, you have dependency injection framework in all programming language, all like all like sort of we have for Java, and the one that we discussed is for Java. But please feel free to explore for other text styles that you're familiar with as well. Where we also have the implementation textual framework. Cool. So thank you so much for your patient with me, and sorry for going late.